In this video, I want to talk about the idea of covalent bonding and ionic bonds, okay? And we need to know what they are and also how to write them, okay? Now for covalent bonding, uh, there's nothing really that's what we're more interested in, but we should know how to write ionic formulas, okay? And so covalent bonds are, it occurs between two or more nonmetals, okay? So nonmetals, so two nonmetals are bonding, okay? And this usually involves the sharing of electrons. So water is a covalent, we have covalent bonds, okay? Glucose, which is sugar, we have covalent bonds. Notice that we have carbon, hydrogen, and oxygen, okay? If I look at the periodic table, we should know by now that pretty much most of these over here are nonmetals, okay? So over here are nonmetals, here are transition metals, and here are alkali metals and earth metals, okay? But pretty much most of the periodic table over here, when we talk about fluorine, chlorine, phosphorus, sulfur, nitrogen, carbon, these are nonmetals, okay? And so because they're nonmetals, only involve nonmetals, we talk about that being a covalent bond. Ion bonds are a little bit different, okay? In this case, we have a metal and a non-metal, and it's usually involves a transferring of electrons, or okay. So sodium chloride or magnesium sulfate is an example where we have ionic bonds being present. And so if I look at the periodic table, notice that sodium is in the first is in that first row, is our first column. It's in that first column, okay. And so we know these to be our alkali metals. These are alkali earth metals. Here's our transition metals, and over here we have our nonmetals. Okay, over here I have our nonmetals. Okay, so notice that sodium is a metal, and notice that chlorine is actually a nonmetal. Okay, and so that's why we have sodium chloride. It's an ionic bond, a bond between a metal and a nonmetal. Okay, now we need to talk more about how to write formulas, okay, especially for ionic formulas, okay. So what if I wanted to write the formula the bond that forms between aluminum and oxygen? What would be a molecular formula? Well, if I take a look at the periodic table, okay, I see that aluminum is in group 3. Okay, so aluminum is in group 3. So we have group 1, 2. We skip the transition metals. We go to group 3, 4, 5, 6, 7, 8. Okay. Now, because aluminum is in group 3, aluminum is a metal. Okay, so aluminum is a metal. And so metals tend to form plus charges. Non-metals tend to form negative charges, okay? And so because aluminum is in group 3, we say this is aluminum 3 plus. Okay. Now look where oxygen is at. Okay. Oxygen is 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is in the sixth column. Okay. Now, we know oxygen is a nonmetal, and so how we memorize this is that the halogens form -1 charges, and 1 over we get -2 charges. So anything, so this would be sulfur 2 minus, okay? Oxygen 2 minus. Anything in this row here, we get 2 minuses. Fluorine, chlorine, bromine, iodine, we get minuses, okay? Now for metals, we get plus charges and then +2 charges, okay? So that's the trend that we should be familiar with. Anything in this column here, we get plus charges. These are +1 charges. Anything this second column here, +2 charges, okay? The halogens, -1 charges. 1 over, we get -2 charges, okay? And so because of that rule, we know oxygen is O2 minus, okay? Now, how do we get the molecular formula? How do we get the molecular formula? We know the charges, but how do we get the molecular formula? And some people like to do math. Again, I don't like to do math. If we could simplify it as much as possible, we're not going to do it. And so what I usually think of is the crisscross rule, okay? And so the only thing I do when I write the charges, I take an arrow and draw from the number to the bottom of the next atom. and do the same thing for the other one. So from the number to the bottom of the next atom. Okay, and so when I write in the molecular formula, the only thing I do is just put the number where the atom, where the arrow tip is at. Okay, so I put them together. So this is aluminum. Notice that 2 is coming here. So this would be aluminum 2. Okay, so it'd be aluminum 2, oxygen 3. Okay, and so this would be the molecular, this would be the ionic formula. Okay, this would be molecular formula. Okay, and so this is how we'd write the molecular formula between aluminum and oxygen. Okay, so let's look at one more. Okay, how would we do it for calcium and oxygen? Well, we know calcium. I'm going to write my charges. So calcium is in, where is calcium? Calcium is in group 2 here. Okay, so we know it's going to give a +2 charge. So the charge in calcium is 2 plus. Okay, it's an ion, and we said ions tend to form plus charges, or metals. Non-metals tend to form negative charges, and so we have aluminum. Well, what is oxygen? Well, oxygen is right beside fluorine and bromine, as we said before. So 1 plus, well, negative charges, negative 1, and then we have -2. So we know the charge in oxygen is -2. So this should be O2 minus. Okay. So when we do a crisscrossing, notice that I'm going to draw my arrow from the number to the bottom of the next atom, and do the same thing for the other one. Okay, so in this case, we actually get Ca2O2. Okay, but here's the deal. When I add calcium 2 plus and oxygen 2 minus, well, actually those will just cancel out, and so the actual molecular formula is CaO. Okay, and so this would be the correct answer, not this one. This is wrong. Okay, so whenever you charges balance out like that, just write the molecular formula and just put them together. Okay, in this case, the 2 charges did not balance. If I had a 3 minus here, then this would be ALO. Okay, that's not the case. Okay, so this is how we write molecular formula, and this rule is just very simple. It works for any formula that you wanna put together. It works for any formula that you want to put together. Okay, it works for any formula that you want to put together.